Okay, Ishita, so I think you can start whenever you're ready. Yeah.
Okay, sure. So I'll just start by introducing myself first. My name's Ishita Moghe. I've been TAing and lecturing in this course for a couple years. I took it as a student in 2017 or 2018. And I really enjoyed kind of what the course was about. I enjoyed how the course kept evolving. Every semester, there's a couple different people. There's people who change their lectures. So it's just a really interesting thing that I enjoy being a part of. So I did my master's in neuroscience and just completed it recently. So I'm going to be touching a bit about my background from that as well. And I'll start sharing my screen now. All right, everyone can see this well?
Yep.
Okay, so my presentation today is going to be about the biotechnological revolution. So I'll be going through some areas of biotechnology that have been rapidly improving and accelerating and have some really exciting developments. And I'll be mostly talking about them in regards to medical applications as well as environmental effects. And what kind of ethical discussions might have to take place as these technologies become more common and commercialized. So in these ethical open-ended questions that I present, I'd love it if we could all just take a few minutes and just chat, have an open discussion about them. Since I find that in so many of these lectures, I try to pre-guess what students are going to say or what students are going to ask, but then when I actually present the lecture, there's so many new interesting things that I realized that I didn't think about before, and I think that's one of the best parts. So at any point, if you have any questions, if you have anything you're confused about or anything, like just anything at all, feel free to speak up. Okay, so I'll be going over a bunch of different topics today. So first I'll be talking about biosensors, bioprinting, tissue engineering, and gene editing. And then briefly at the end, I'll also go through biomanufacturing and neurotech, just to kind of give a overall approach to the different kind of biotechnological applications that are being developed. So first, I'll talk about biosensors. So what is a biosensor? It's an analytical device that's used for the detection of chemical or physiochemical cues. So it interacts or reacts with a compound. And many biosensors are common and have been used for years. So think of things like pacemakers that are implanted in or near someone's heart to regulate their heartbeat. But researchers currently are trying to make smaller, more reliable biosensors for a greater variety of purposes. So firstly, do any of you use biosensors in daily life that you know of?
So the students in the room are shaking their head or looking quizzical. None of them are nodding.
Okay.
No nod.
So do any of you have or use an Apple Watch or a Fitbit or anything like that in daily life? It's basically a preliminary biosensor. Like it's pretty basic in terms of what it senses. It senses your heartbeat, it senses your pulse and things like that, but it is a preliminary biosensor. So many people have adopted things like Apple Watches or Fitbit, which track their daily movement, their daily activity level, things like that, their sleeping habits. Would anyone here be open to adopting a tiny little biosensor chip that could just be implanted just beneath the skin in a pretty convenient place, minimally invasive procedure? Does that sound like anything you guys would ever consider doing in your lifetime? Do you think that's too invasive, or do you think possibly you could consider getting it if everyone else was getting it?
Would that be like the same kind of concept as like a Fitbit though, where it's like kind of like looking at like your steps and your heart rate and stuff like that, or like what would it be used for?
What would you be okay with it being used for?
It's fair.
Like, okay, so I'll give you some examples of things that are being developed. So there's currently chips being developed for real-time monitoring of drugs. So it allows doctors to look at real-time effects of drugs on your metabolism, which could lead to a whole new generation of personalized treatment and precision therapies. So these things can measure pH, they can measure temperature, metabolism-related molecules like glucose and cholesterol. So using this, your doctor could tailor pretty specific drug schedules or therapies for you. Would you be okay with that? I'm seeing some nods. Yeah, like if it's for your benefit, it's for your health treatment, then maybe yeah. What if it could also detect and read DNA mutations? So a biomedical implant that could find these DNA mutations and transmit the data wirelessly to a mobile device. That's actually something that's being developed at UC San Diego right now. So if we go even further, what about a biosensor that could detect specific molecules associated with neurodegenerative diseases or cancer? So there actually is a device designed to react when it comes in contact with an enzyme that is linked with all of these disorders. So would you guys be okay with that? I think many people would. I don't want to speak for everyone, but from what I've heard, and maybe speaking personally for myself, if there was a biosensor that wouldn't really affect my daily life, but it could tell me early markers or signs of something that could severely affect me later in life, I think I might opt in for that. So obviously this leads to a lot of ethical considerations as well. So things like using them with a vulnerable population. So what if you or someone in your family had a history of some cancer or some illness? Would you opt in to get your child to have that implant at a young age as a preventative measure, so that if anything, if they had any kind of genetic predisposition to any of these illnesses, you would know sooner rather than later, and you could actually take steps earlier to prevent it? Do you think this is something that could be used with these vulnerable populations?
Well, it's complicated, right? Because some people who are in a family with terrible genetic problems don't want to know, because if you find out that you're going to get something horrible, it really interferes with your life more than if you just wait until it actually happens. So yeah, and it's hard to predict what people's feelings are going to be. You know, it's not a decision you can easily make for somebody else, because the person might say, yes, I want to know. You know, I want to know as soon as possible. I want to know at the age of 15 whether, you know, I'm going to be a complete vegetable at the age of 40 or something, you know? So, yeah.
I also have a comment kind of to go off of Dr. Solaz's point too, but just especially if it's a disease where we don't really know how to prevent it, like, would it really be helpful telling the person in advance if they know there's nothing that they can do about it? Like, that's another thing to consider.
Yeah.
Yeah, and I think like maybe for like treatments where, like say for like MS, where you can kind of stop or slow the progression, for those it might be helpful to maybe get alerted once it's already happening, but like maybe to be like, oh yeah, you're gonna develop this disease in 14 years and 29 minutes, that might not be the best, but like once it's already happening, then it's good to know before, so you can stop it as early on as possible.
Yeah. I also think it's interesting, even if we're not talking from a preventative sense, what about implanting these kind of biosensors in elderly patients who have some kind of disorder where they can't actually take care of themselves? Is it ethical to basically chip someone in order to consistently monitor their health, even if it's not something they directly can consent to, but it might actually help them in the long run? I also feel like we have to consider the fact, based on what you guys were saying, it might be difficult or might not be desirable to know these kind of things beforehand if there's no preventative, if it's not preventable. But if everyone around you is getting these things, would that not also make it even more difficult to not get it, to not know what's coming if other people know what's coming? So another pretty important aspect of this is patient compliance at home. So this is also related to what I mentioned earlier about people in care homes or who have neurodegenerative disorders where they're not fully able to care for themselves. So just knowing when something needs topping up, when they need certain medication, when something's working and when something's not. And even we can talk about more basic things with this too. So what if you have a biosensor that's implanted and it just texts you like, hey, you should have some vitamin D pills today because you're feeling really down and you're deficient. Or your cortisol levels are high today, maybe take some time to rest. Or it could even be things like using them for diabetic people, like your glucose levels are dropping, maybe you should have a juice box right now. So the applications of this are pretty limitless. And it seems like with all of the new developments that are coming, you can use biosensors to regulate hormone levels, or to look at how drugs are affecting you, to look at genetic mutations. It seems that it seems very likely that these kind of biosensors will be used more frequently and for a more wide variety of purposes in the future. So it's really interesting to think about our own personal limits of what we'd allow for ourselves and what we'd allow for other people in society. So just expanding off of that, I think you've talked about this before in, I think, Dr. Zayan's lecture, but there are also, of course, non-medical implanted devices as well. So I think you saw the example of the Wi-Fi implant that told you like when you're close to free public Wi-Fi. So what about things like phones, communications, cameras, or just any other enhancers? Like it's not preventing any kind of health issues for you, but it's actually enhancing your quality of life. You're actually able to see better or hear better, or you're able to take high def pictures just with a snap or something like that. Does your limit for implanted devices end at this is good for my health, or would you also be willing to enhance what you have with these kind of implants? Does anyone have any thoughts about this? I'm pretty interested in hearing other people's opinions. Yeah, go ahead, Tasmin.
When you talk about these like implants and stuff, what I'm mainly thinking about is what if I break it inside? Then like what happens with all that stuff? Where does it go? And also like if it's signaling right, then how will that interfere with like my nervous system in that area or my blood flow in that area? Because like there's a device there and it's putting pressure on my tissues, right? Just a thought.
I think that's interesting. I think the precursors to these kind of, I guess more like leisure implants rather than actual health implants would be things like pacemakers, things like that. And those, of course, with any invasive surgery, there's always risks of things happening. With pacemakers, I think the biggest issue is the leads, the actual wires have the ability to disconnect or to shift to a place where they're not supposed to be, which leads to another surgery to correct that. And regardless, pacemakers have to be swapped out, I think, every 10 to 15 years. I'm not sure. I think they might have improved on that, but there are considerations like that. But we're assuming that these kind of biosensors would be pretty close to the skin, since it doesn't have a function with any of your organs specifically. So ideally, in that case, you would be able to charge it without taking it out or like plugging anything in. So yeah, these are meant to be pretty low maintenance, pretty easy to fiddle with, basically. So if you're disregarding the safety issues or like the implantation issues, would you be fine with this in terms of privacy, in terms of having your biological information shared to other people other than yourself?
I guess for me, it kind of goes back to your point about, like, for me, I wouldn't be comfortable with it, but if everyone else has it, then that changes things. Like, I'm just thinking, for example, having cell phones, like, if you only have a landline, like in this day and age, it's hard for you to really, I guess, integrate with everyone else unless you actually have that cell phone. So if everyone has these non-medical devices, it might make it more difficult for me if I say I'm not going to get it just because I'm not comfortable with it.
Yeah, I think, we may feel about ourselves that, conformity is just never a motivator for us, but that's not really true. Like when the, design of the Coke Zero bottle occurred a few months ago, I really didn't like the new brand. So I saved up all these old ones so I could keep using. But this week, I've decided that I like the new one better. Why is that? It's because I'm seeing it everywhere and everybody else is drinking the new one and so on. So even I am clearly influenced by what other people are doing, and so I think a lot of things about the way you behave in the future will be motivated by that, by what people think is normal life and cool to do,
Also, I just wanted to say, I think, interestingly, for some reason, I'm thinking of these quote unquote invasive things that we're doing as other forms of other medical equipment that we have. So in a way, what is the real difference between if for example, this implant that we're doing, if it's serving the exact same purpose as, oh no, not exact same purpose. If it's serving a specific purpose, what is its difference from a current medical technology that we're using? It's just more efficient. That's a perspective. Because I feel like if it's more general, then I understand the ethical considerations. But if it's serving one purpose, hey, we're just checking your blood sugar levels for this, then it's kind of cool. I don't know. And then for non-medical implanted devices, that's crazy. That's that's so many ethical considerations. So I just wanted to bring that up.
Yeah, there's a fascinating history with this course in Europe. There's a guy who's one of the leaders of this movement to, implant chips in yourself for all sorts of things, so you can open doors and unlock safes nobody else can. Whatever you want to use the chip for is possible. So he was going to come here, visit me, speak in the course, and so on. But there was a kind of non-medical disinformation part of it. The whole movement has kind of they're pretending that they're doing it to help people's health, but it's actually sort of a cult, right? So he had this constant tension between the fact that he's a cult leader and it has nothing to do with medicine, but you can use the same kind of chips to do valid medical stuff. And in the end, before the pandemic started, he wound down all the plans for the trip because he didn't want to be, confronted by us about this stuff. So really interesting to watch that whole sequence. Yeah. So
I just think it's super interesting, like how like broad the spectrum is of just like how much everyone is on board with this. Because there's this girl on the internet who she got like RFID chips just like right here and like in between her fingers, and she uses that for like doors. She used it to like baby proof her apartment basically.
right.
So all of her cabinets, everything only open with that. And then like some of the comments like, this is so aesthetically pleasing, this is so convenient, you don't have to worry about anything, there's no ugly like baby bulky whatever's on all of your doors. And then the other comments are like, no, you're actually crazy. Like just put the thing on your door, like you don't have to get anything implanted. So I just think it's so crazy how like today everyone like we live in the same society, right? But it's just like some people are completely like, no, like this is the way to go, and other people are like, no.
I think, sorry, it's someone else. Oh yeah, Tasmin, go ahead. I'll speak after.
No, you can go first.
Okay, I was just gonna make a small comment on the last thing that was said. I think it's interesting because I feel like it'll just take like 20 years to shift that. Like kids who grow up seeing that, they're not gonna have like any issues with it. Like when they get into their teenage years, they're like, this is fine. We grew up with this. Like it's gonna be so quick once these things start getting adopted. Go ahead, Tasmin.
Okay. So to the question of whether I would want it, I think in the end, my final decision would be based on what the legal parameters are for what information the industries are allowed to use for me. Because as we can already see with like social networking type stuff, there's already so many issues of security and like how they're using our information. People don't feel safe like sharing like their cookies and all that stuff. So I think that would probably be my biggest factor in deciding of whether I want to do this or not.
Yeah, it's so tricky because even speaking like on my experience, I feel like it's so hard because we keep seeing every day these news stories about what different phone companies or like Google or Facebook are collecting from us. And then every time I'm like, oh my God, I need to do something about it. Like I refuse to get TikTok because I think it's bad or something. But at the same time, I still have all of these things. I still have an iPhone. I still have a Facebook account. I still have Instagram, everything, because everyone else does. So I still want to be connected with everyone. I still want to be a part of the generational experience. So it's so difficult because in my head, I don't like what's happening with my information, but I'm still voluntarily doing it, you know? Okay, if there's no other comments, I will move on. Does anyone have any last things to add? Okay, I'll keep going. So the second topic I wanted to talk about is bioprinting and its uses in regenerative medicine. So if you aren't familiar with it, bioprinting is the utilization of 3D printing like methods to combine cells, growth factors, and other biomaterials to fabricate basically medical parts, things like organs, joints, tissues, things like that. So I'll just briefly go over the process just so everyone can understand kind of what's happening. So first, a cell sample is obtained from a healthy human participant or a cell bank. And this ink, this 3D printing ink is made by expanding the cell culture and combining it with biomaterials. So these biomaterials usually include some kind of gel or some kind of glycol as an ink. And companies are getting really good at making this ink with a cell viability rate of over 95%. So the 3D structure is printed layer by layer. And this is a quote I found from one of these companies that is currently making human bioprinting organs, that artificial human tissue is created with the same composition, architecture, and functionality of the real human one. I wanted to quote that because I don't know if I'm convinced enough that I could say that 3D bioprinted organs have the exact same composition, architecture, and functionality of a real human one, but that is what companies are aiming to make and claiming that they're currently making. So obviously with this, we'll have our own set of ethical considerations. So concerns of the stem cell source. So embryonic stem cells have long been met with moral and ethical concerns. So people have started using induced pluripotent stem cells, which are made from just healthy human adult cells. And then they're induced back into a state of pluripotency. But these, of course, also have risks of mutations and a higher risk of tumorigenicity, which is a major problem when using iPSCs. There's also, as you'll see, this is a recurring theme in most of the different biotechnological fields I'll be talking about. There's not very much legislation. There's no universal legislation. So what few laws and rules and regulations there are, it's very based on specific places, like a country or a state or a specific institution. So it's not at all universal. So essentially there's very little legislation regarding any of the ownership, processing, or storage of genetic information. And we also have to wonder who is in charge of digitizing anatomy. So if I'm trying to 3D print some kind of organ, like let's say a liver, who's in charge of actually creating that 3D model of a liver? Is it a physician, a biologist, engineers, computer scientists? If something is incorrect or if something doesn't function the way it's supposed to, then who takes responsibility for that? And then, of course, as with most things, we have to think about the social stratification of organ printing. So obviously, regenerative medicine and human bioprinting could be a huge plus for the organ transplant community, since it's obviously a difficult and long process to find an organ transplant should you need one. And this could be a great way of making organ transplants organs easier and more reliable to come by. But we can probably guess and expect that people who are richer, who have more economic means, and overall countries that are richer will have access to this way before other people in other countries. So we also have to think about that, and which people would actually be able to get these kind of transplants. Because currently there are some companies trying to make things like 3D printed ovaries, and ovaries are not necessarily something that is required to live. So this would be more of a voluntary procedure rather than necessary or life-saving. So this is for people who have maybe had a cancer that metastasized in the ovaries. So would people who wanted an ovary transplant have an age limit? Would people be prevented from getting one if they had previous children? Like, would people who didn't have children maybe take priority? So there's like a lot of different considerations that have to take place before these kind of things can actually be distributed. So does anyone have any thoughts about any of these ethical questions that I just threw at you? I know there were a lot.
Well, I just wanted to point out what happened So on the 16th of this month, we had a presentation, Robert Montgomery and me and Brad Ferris, about pig to human transplants. And what you need to realize is that the last 10 years have turned out very differently from what I thought. I thought in 2011 that the transplant community needed to be prepared for tissue engineering generated organs. And I started to do that, was reasonably successful. So by 2017, all the different organ areas agreed that they'd start planning on how they would analyze stem cell generated organs in their area, liver, heart, pancreas, so on. You know, so from a political point of view, it was amazing what I was able to accomplish. But then when this first pig to human transplant was done, I realized that this regenerative medicine created organs has not progressed as rapidly as I thought. I thought there was big urgency to get people to prepare. And here it is, 2021, 10 years later, and we don't really have these things yet. On the other hand, I could have been talking about preparing for implanting pig organs, and that is something that seems to be starting. So why, and Bob and I talked about this on the 16th, but just to reiterate, just exactly what you're talking about on this slide, artificial human tissue with the same composition, architecture, and functionality as the real human one. That is what doesn't seem to be possible for complex organs now. And you may have heard me talk about in the kidney, you get podocytes, which are ordinarily only in glomeruli, wandering around in the interstitium, the space between the tubules. And that may just seem funny to you, but it's a sort of metaphor for a huge problem, that at that capillary level, there are not really any collagen structures that can be templates for where the cells are supposed to go. So you squirt the cells in, they have no idea in the interstitium what to do. In the glomeruli, in the bigger blood vessels, they can figure out what they're supposed to be doing. But so in all complex organs at the present time, regenerative medicine induced or created organs don't really work, because at the capillary level, the cell types are all mixed up and not creating clear-cut capillaries the way they would in a normal organ. On the other hand, if you're a pig and if you've got pig organs, you don't have that problem. Pig organ capillaries know what to do, and they're in the right place and so on. Yeah, so I think that quote is what we thought was going to be the case, but is not the case in 2021, that you can't actually create exactly the same architecture.
Tasmin, did you have something to say?
Hello. So also kind of similar to what Professor Solis was talking about, I wonder what would be, so on the terms of these organs functioning in the body as a whole, like with more nuanced functions like endocrine functions and signaling to other organs and pathways that we don't completely understand, I wonder how that would be impacted in these bioprinted organs. And also in another stream, when they make these types of organs, I wonder who they would be modeling it after. In the Western society, you could expect them to be modeling after white patients, but we also know that different races have different like hormones and different just general physical genetic like abilities and enzymes and stuff, right? Like lactose intolerance is dominant in like 70% of the population, but 30% are not as commonly lactose intolerant, and those kinds of things. I think there would be some considerations and like more, more specific requirements once we actually get this going to be able to adapt it for all people.
Yeah, no, I think that's absolutely right. I mean, even if you compare the ovary and the thyroid, like the thyroid is actually, it's pretty simple the way the thyroid works. And so even if stem cell generated thyroid isn't particularly responsive to hormones and so on, would still probably work okay. But you don't need a thyroid transplant anyway, because you can just take a pill that gives you what the thyroid's producing, right? So, but even when you go from the thyroid to the ovary, I think probably the ovarian function influence of various hormones and so on would not be the same as it is with natural ovary, and that might make a difference. Yeah.
Does anyone else? Yeah, go ahead.
I also have concerns about like who would patent these, like who would have ownership over these certain ways of like producing bioprinted organs and stuff. And also like who could, as mentioned before, as has been said, there's like different ways that you could make a bioprinted organ. And this would vary based on the characteristics of the person you're basing it on. So potentially people could patent all of these different varieties of bioprinted organs and restrict access to them and like put it behind a really high cost, etc. So yes, I feel like that could be inhibitive for people to like afford these if they really need it,
Yeah, that's a really interesting point. And it's actually something that I also wanted to bring up with the next topic too. I'll just go to it because I think it's a very interesting topic. So tissue engineering, which is, I'm sure you've all heard of in this course at least, but we'll basically be talking about process of using viable cells and bioreactors and often scaffolding to create tissues, joints, and organs. So it's very similar to 3D printing, except it's not actually using a 3D printer to create these organs or tissues. You're allowing the cells to grow by themselves more naturally, but still in an unnatural environment, like in an in vitro environment. So I wanted to talk about meat cultivation because oftentimes when we're talking about humans' environmental impacts and the environmental crisis that we're going through, we sometimes skip the huge impact that the meat industry has. So I have a couple stats here because I just thought it was very interesting. The meat and dairy industry create 7.1 gigatons of greenhouse gases annually, which is 14.5% of total man-made emissions. So it's a pretty huge impact. And to illustrate the difference between meat and plant-based food production, 1 kilogram of wheat produces 2.5 kilograms of greenhouse gas emissions, while 1 kilogram of beef produces 70 kilograms of emissions. So it's pretty significant. And in addition to that, traditional meat production also has to deal with other ethical concerns such as overuse of antibiotics, food safety, and poor animal welfare. So in contrast, meat cultivation is basically the in vitro growth of different meat tissues and organs for the purpose of consumption. So the process, I'll just go over it briefly since it's not necessarily important for our ethical discussion, is that initial cell samples are collected from a healthy animal and stored in a cell bank. And this obviously, they have to take a lot of considerations when choosing the initial cell line, like suitability for growing, metabolism, as well as different things like taste of the meat, texture of the meat, things like that. It's placed in a tissue cultivator, otherwise known as a bioreactor, which basically mimics the internal environment, biological environment to kind of encourage growth of this organ and tissue. It's provided with a plant-based scaffolding, which are generally things like cellulose or some kind of plant protein. And they're meant to be either biodegradable so that they can be replaced by the animal cells before consumption, or they're safe for consumption and they stay with the tissue the whole time. And then this tissue or organ is harvested and ready for consumption. So the thing I wanted to talk about based on the last comment that was made is this, private versus public cell repositories. So manufacturers, people who are already cultivating meat for consumption as an alternative to traditional meat, people are already patenting or privatizing specific cell lines that they use. So it's already creating a huge barrier for people for new companies or for other people to kind of get into this meat cultivation space. So they research and select or develop their own cell lines for cultivating meat. And this advances the company's own production value, but it also creates this burden of entry for anyone else trying to cultivate meat and be a more responsible citizen on Earth in terms of the environmental impacts. So this, as you said, also applies to tissue regeneration for humans as well. Like I think in a lot of companies, in a lot of fields, we can already predict that these things will be privatized and they'll be kind of held close to the chest for a lot of these companies since that's their main way of making money. So is this something that you think should be publicly available? Does that defeat the purpose of this kind of commercialization? Or do you think, I don't know, what are your thoughts on this?
I think the idea of it being privatized is definitely a big motivator to speed up its progression and its like development. Like ideally, as a society, it'd be better, I think, for it to be public and like handled by maybe not per se the government, but by the public. But like I feel like it would also really slow down if there's no money really incentive.
Yeah.
Then it would, we kind of have to rely on the goodwill of people and like wanting to just like the helping portion, which would work, but slower than the financial incentive.
When you look at electronic records of medical publications, for instance, in the beginning, that was all a for-profit enterprise. And, you know, there's a lot of money made by companies providing access to these databases that are now free. And gradually it was realized that the benefit of making it free would just be enormous, you know, and that there were no inherent costs really. It's like, it was pure profit. It wasn't that people had to dig holes in the ground or something to get this, right? So I think something similar will likely happen here. And it's not unlike the situation with cell phones and TVs. The first TVs were really expensive, the first cell phones were, and so on. But, you know, the public pressure just, everybody wanted the thing, and Yeah, so, and it's also quite interesting to think about the cost of the research going into the electronics. Like when you hold your cell phone in your hand, it's like probably billions of dollars of research has gone in to create this product. But it's all sorts of companies competing with others. So you don't end up paying for it. It was paid for a long time ago. Right? So the same kind of transition will occur here as long as the population thinks this is a mainstream need, that normal life now requires this. So it should just be easy and inexpensive. Yeah.
Well, it could work like other medicine, though, because like, correct me if I'm wrong, but the way I understand it is like the first like couple years or whatever, the company comes up with a new medication, they have the rights to it, but then after a while they have to like release the recipe, and then you can make the off-brand, same medicine, same active ingredient, but like off-brand.
Yes.
So it
yeah.
could be like that, where like
Yeah.
you said, yeah, kind of like the first couple years it's crazy expensive, just the one company monopolizes it, and then after a while they have to kind of give up the rights and share it.
Yeah, then there's a whole thing of orphan drugs, like drugs that are used for really specialized things. You can charge an enormous amount for them and so on, right? But what about like types of meat that most people don't want, but other people really, really desire, right? Will that also be enormously expensive and a huge profit built in? I don't know.
Yeah.
So just have to see what happens.
I think one thing that I'm worried about is the current, so I like this idea for one. I mean, I heard about it and I was like, ooh, exciting. Wow. I don't eat beef, but I'm like, oh, cool. People can ethically eat beef now, crazy. But I do worry, like kind of like how right now the oil situation where oil prices are going down and you have this large just large quantity of people who have specialized, who now like are losing jobs and aren't able to like find alternatives without help. I think like that has to be considered, where like this alternative is now removing this ancient way of like farming, and like there's generations of people all over the world who are farmers, right? And their livelihood is at stake, and that's a real thing. At stake. I'm sorry, but but yeah, I think there has to be like probably some kind of framework to help these people move on and find a way that is like they're able to make money, because I don't think that, like, especially if they privatize these cell line repositories, these farmers aren't able to like transition easily into this line of work.
Yeah. But I was telling you about Oroville in India. I visited there in the 90s, and so they haven't used money for a very long time. And if you look at a Star Trek episode, you can see that also in the Star Trek world, they weren't using money, right? So probably orienting all your thinking about, well, what's going to happen about the money someday, that won't be an important consideration at all. So.
Okay, I had a few other questions just to think about on here. Are traditional meat suppliers punished? So this, again, I was going back to the social stratification. If, and like what you were saying about traditional farmers, about traditional forms of meat production. If people are unable to adopt the new way of doing things, if certain countries don't have the funding or aren't able to buy out the information for these private cell line repositories, will they be taxed higher? Will they be punished for not being able to keep up with meat cultivation, the new way compared to the traditional way? And then also, are cultivated organs or cloned animals given the same moral status as normal ones? So cloned animals, I didn't really talk about much here, but they're already used around the world. Cattle are being cloned for their prime quality beef. Horses are being cloned for their agility or their jumping abilities as polo horses, or for other kind of things. I don't know what horses are used for in sports, but for their great abilities, their physical abilities. So are they protected under the same laws? How do we even keep track of them? Like usually these kind of animals are pretty well documented when they move place to place, things like that, how they're bred. How do we keep track of cloned or cultivated animals and organs? And are they protected under the same legislation as normal ones? So
Yeah,
these are
so the first transplanted pig kidney, of course, it wasn't just a normal pig. It was a pig that had been genetically modified, so it didn't have the antigens that we all have antibodies to. So, people, even though the time has been short, I mean, it's between October 21st and now when people have been realizing we're in a new era. But see what you think about this. Some people are thinking that in the kidney transplant world, since you can live with one kidney, that you wouldn't have to sacrifice the pig, right? Just take one kidney and let it live with the other one, and people would be much happier to receive, and you could even visit your donor. You could go to the pig farm and shake hands or shake paws or whatever with the pig that gave you the organ, So what do you think about that? Is that important? Is that foolish? Does it not matter at all? I don't know. What are your thoughts?
I think that like morally that can be important to a lot of people. Like I think it's one of those things where some people care and some people are like, oh well, whatever, it's a pig.
Yeah.
But I think it would attract a larger audience and make it more normalized and more widely accepted if that was an option. Because to a lot of people, more and more, especially these days, it is becoming super important that they are ethically sourced. And we're kind of going towards that with all of our products, not just our internal organs.
Yeah. Yeah, and I mean, pigs actually, in terms of their intellect, are smarter than a lot of other animals. So you can prove that. So even though we routinely eat them, but that's true of squid, octopus. I mean, if you had a pet squid, or why don't you? The reason you don't have a pet squid is the squid would outthink you regularly and figure out all sorts of ways to make your life a living hell. It would squirt water in your eye and get out of its tank during the night and do things that you don't like, and yeah. So it is a real consideration. Where do we draw the line, right? So maybe we shouldn't eat meat at all, and so on. Yeah.
Okay, so I'll move on to my next topic. I expect this one will also have, I'll be able to hear lots of people's thoughts because this is always a polarizing issue. Gene editing is basically the genetic engineering of DNA, where certain things that you want are inserted, deleted, or modified in the genome of an organism. So I'm sure a few of you are familiar with the CRISPR-Cas9 system. So it's one of the more popular gene editing platforms. I won't go into a lot of detail, but essentially, as you can see in this clip right here, the system induces DNA breaks and then reinserts your desired code into that location. So you might have heard of a high-profile gene editing case from November 2018, in which 2 human children were gene edited, and then they were actually given birth to. So usually when embryos have some genetic editing done on them for research, they are disposed of after 14 days. They're not allowed to develop further, and they're definitely not implanted back into a woman for her to give birth to. So in this case, men, it was a couple who would come in, the men had HIV, the women did not. So they wanted to create embryos and have children that would actually be resistant to HIV. So there is some subset of our population of humans that are naturally resistant to HIV. And these people have a mutation in the CCR5 gene. And this is what the researchers tried to mimic. They tried to mutate the CCR5 gene to create that, addition to make these embryos resistant to getting HIV. So in the results that were published, there was some mosaicism. So some cells had the mutation, some didn't. So it wasn't exactly sure if these embryos would be fully resistant to HIV. And the interesting thing is the announcement of the birth of these gene edited babies is when it first went public, because before that it was all kept private. And originally the announcement was praised. People thought this is the next big medical innovation. It was a huge step, since no one had come close to doing anything like this before. But soon after it started spreading, it came under a lot of fire. They got a lot of scrutiny from scientists and basically most people around the world. And this ended up with the lead researcher in this case, Dr. Ha, got charged with 3 years in prison and got a financial penalty as well. He defended his research, but he pled guilty. So this was a very polarizing case. Lots of people thought it was really interesting. As a scientist, I think it's really cool. I don't know if I excuse all the ethical issues that were in this case. For example, forging ethical review papers, things like that. Obviously, I don't agree with that. But we also can't deny that this is a great medical advancement, right? It's an innovation that hadn't been done before, and it was shown that this kind of thing is possible. And it opens the doors to a lot of different applications of this in the future. So obviously this comes with its own host of ethical considerations. Again, there's a lack of legislation. So even if in a certain place, someone isn't allowed to sell embryos, or someone isn't allowed to genetically edit embryos, why not just take a flight somewhere else? Like take a $500 flight to Russia and do it instead, and then come back. Like if it's so easy to do it, why not? And if there are no universal legislations, it makes it pretty easy to bypass your local legislations. Why is selling most body parts illegal, but not eggs? What are the consequences for breaking these kind of laws? The researcher in this case obviously got sent to prison, but what about the parents who knowingly and voluntarily did this? What happens to the babies? Oh, sorry, that was my last question here. But essentially, these are all a lot of issues that came up with this. So I just wanted to hear your thoughts. Like, is this the next big thing? Like someone had to do it, so let's just see if it can be done? Or do you think, I don't like, what do you guys think about this? Anyone? Oh yeah, go ahead, Tasmin.
Has anybody watched Gundam? Okay, so basically it's a show, and the plot is that there's 2 types of humanity. and one of them is all like edited humans. They're all like advanced, more powerful, they're smarter, they're faster, etc. And the other ones are called naturals. So they're natural humans and they haven't been gene edited. And basically the two sides of humanity are always competing and they're always at war with each other. And I feel like that is potentially something we should be expecting in the future with people like who are bio enhanced versus the people who are against that. Yeah, I think we can definitely expect that because it's a really interesting concept and there's definitely a lot of like there's a lot of stuff in life that you wish you had control over that you don't, and I can see people wanting to have control over that for their kids because you know it's available, why not?
Hello.
I think it's very interesting. But this reminds me in a way of like how do I say this? I guess a lot of medical breakthroughs, right? For example, have happened in like weird ways. So I know that, for example, war is a way that medical breakthroughs happen. So like after World War II stuff happened. I know specifically after the Japan, Korea, China thing happened, there was like a bunch of medical breakthroughs. So like in a way, like it happened. So like I guess we got to learn from it and move forward. Do I like that it happened? No, I think that it makes me a little bit uncomfortable. But since it happened, we can maybe try to move forward. I don't know. That's my thoughts. I have thoughts.
Do you think
Yes.
the researcher should be villainized like he is being like punished
think
right now?
He's not villainized. I feel like he did something wrong, so now punishment happens because he did something wrong. Like I understand why he defended his research, but then I'm not sure. I haven't like caught up with any of the laws. I mean, not the law. Sorry, the story itself. But you mentioned that they were forged ethical papers.
Yeah.
So, see that is what he's being punished for. You know, like I feel like going through the motions, doing it the hard way is what like he should be reprimanded for. But the science in itself is like, I guess in a way it's just research, right? But yeah, that's my thoughts. It is hard to say that though, because inside I'm like, something about this feels so wrong. This is so bad. The poor kids. I feel really bad for the kids. Honestly, they have no say in this. So yeah, okay, bye-bye.
So there's a couple of things in chat. I think selling eggs isn't illegal because no one has to die to produce them. I think that's a really interesting take. It's true they don't have to die to produce them, but it's still a invasive procedure that could have health complications. So then why couldn't I just offer something on eBay like, hey, I have this blood type and I have an extra kidney. If you're willing to pay me $500,000, I will be a kidney donor for you. Like, I won't die. Like most of the time, this kind of surgery wouldn't kill me, but I don't think that's legal at least. And I also, okay, the next comment was, did the modified babies have any other health consequences? So this is interesting because the babies, they were reported on right after birth. There was actually a third baby born from another mother a few months after that as well. But we didn't get their real names. Like none of this was publicly released. Their real names, no information about the family. And I recently checked before this lecture to see if there were any updates, and nothing has been publicly released. So it seems like they're trying to protect the privacy of the family and the babies, which is good. But that also means that we are not getting any information past that. So I don't know. Any other thoughts about this?
Just a general thought, but like thinking about things like racism, sexism, like ableism, like those are already over things that like we already have so many conflicts over things like that if we do gene editing. I feel like that's like intentionally choosing to make another, I guess, aspect or framework where people can be discriminated against. So that's why, even though I can see how it's good for medicine, I still can't really feel super comfortable with it yet.
Yeah, it would definitely be, I feel it would just be whoever is the most privileged gets to do it, you know? Like even the privilege of deciding whether or not you want to do it ethically, because for a lot of people, there's no way that they'd be able to access this kind of technology. So it's not even a question for them. So in the case of having, you know, groups who are genetically modified and groups who aren't genetically modified, we can already tell that it's going to be, you know, the people who have the means, the people who are born in Western countries, who have parents who have a lot of extra money. Those are going to be the kids who are genetically modified. So on top of their economic benefits, they now also have this other step up. So it is interesting to think about those kind of social considerations as well. Okay, I'll go through the next sections pretty quickly. So I just wanted to briefly mention some applications of biomanufacturing that have the potential to help the environment. So these next two sections don't have a lot of ethical issues surrounding them. So I think I can get through this in the next 10 minutes. So some interesting applications that you may not have heard of is protein production, for example. So previous data and AI are used to help make protein designs. And rather than using single-use bioreactors like what is used today to make protein vectors and antibodies, some companies, some groups have started using black fly larvae as mini bioreactors. So they use CRISPR to transform the larvae to continuously produce the protein of interest. And then that protein can be used as a vector for vaccines or antibodies and basically advanced vaccine production, which is very interesting. And then the second application I wanted to mention is gas fermentation. So as I mentioned before, raising cattle for slaughter have a lot of environmental impacts. And one of the biggest, not one of the biggest, I guess methane would probably be the biggest, but another significant impacting factor in this is animal feed. Since animals like cows actually consume more food than they produce. So this is an interesting application to use carbon dioxide in the air and use the fermentation process of carbon dioxide to convert it to protein products. So these protein products can be actually used and put back into animal feed to make the entire process a more closed process and a more renewable process. So these are some interesting biomanufacturing applications using these kind of technologies. And finally, last section, I wanted to talk about neurotech and augmented or virtual reality, since this is more of my field and I just think it's super exciting. So you may have heard of brain-computer interfaces. It's essentially, it provides assistance for anyone with functional limitations, whether it be controlling a wheelchair, communicating, or basically a whole lot of functions. So it's essentially using a EEG cap for recording neural electrical activity, and these neural inputs are interpreted and signals are sent to carry out a specific action. So it could be as simple as turning on a light by counting to 5 in your head, something like that, or thinking of a certain color or how to spell a certain word. And then your wheelchair can go either straight or left or right. So it's very interesting. And there's a lot of cool applications for this currently happening. And then in terms of augmented and virtual reality, I just wanted to show this clip from my own master's project because it's a little plug for my research. But essentially, alternate reality, virtual reality, they can be used for things like pain management, anxiety, physical therapy. What I used augmented reality for was with kids with autism and ADHD. So this is just an animation of a kid with autism in this virtual reality environment. So they essentially have these paddles for their hands and they can see different shapes and basically play pong with them. And these kind of games help us understand movement, decision-making, executive function, to characterize how different people's brains work, how different people make decisions, how they decide, how their sensory motor systems work. And finally, virtual and augmented reality can also be used by physicians as well, to train people for surgical planning, things like that. So there are, again, a wide variety of applications that this could be used for. So this is my last slide. Just overall, I just wanted to talk about this kind of conceptual shift of medicine and what the role of a physician is, not just in a medical health related way, but also in a social way, the social role of physicians in medicine. Although traditionally the usual scheme of things is that a patient has an illness, they come in, get treated, and then the aim is that they're no longer a patient. But through this shift, using things like biosensors, things that can enhance us, things that can improve things that aren't necessarily broken. So a patient that is healthy in any other way can come in and actually get an enhancement to make that patient no longer, but also a more, I guess, more optimal, more enhanced version of them. So that's all I had for you today. So thank you for listening. And if you guys want to talk about anything that I've gone over or just anything other than that, I would love to stay and chat.
Okay, any questions, discussion? Yeah.
I have a question just because I'm in my bachelor's of neuroscience. So I think it's super cool what you're doing. So I was just wondering, with neuroscience, do you feel like there's going to be a shift in like how there's more of an emphasis on like things like virtual reality, brain computer interfaces? I was just curious because, yeah.
I do think like in terms of industry and application, I think there is currently a shift happening in terms of it's going more towards biomedical technology, neurotechnology, so biomedical engineering. So I think in terms of if you are more interested in academia and research, then I feel like pure neuroscience is great for that because there's still a lot of basic science that needs to be done in order to support the industry. But if you're more interested in actual applications, if you're interested in like industry jobs, then I feel like neurotech and biotech is becoming more and more important because it's more focused on like, you know, commercialization and bringing different things to the consumer, which is very based on technology.
Other questions? So I've got 4 minutes. Okay, maybe I'll talk about both the 30th and then the presentations. So I don't know what's going to happen on the 30th at all. There are various options. We can cancel the class. Shauna has a number of themes other than augmented reality that she can talk about. So if the AR, VR, XR stuff isn't working out, she could talk about something else, or maybe the AR, XR, VR will work out. Yeah, so I don't know. I will let you know as soon as I find out. Then the 8 of you should maybe let me know if there's something urgent about which day you want to present or whatever. I think I'm prepared to set up in this room every day of the presentations. So even if, you know, Tasmin is the only one who actually wants to present in this room, we can watch the presentations in this room and have, you know, discussion based from the room if somebody wants. So we will have the room set up and ready with a hybrid system here all 3 days. Yeah, so that's basically the deal. I would also, the rest of your midterms are graded and we're just waiting for Shauna's part. So as soon as I get that, I'll you know, communicate with each of you about that. So any questions about those housekeeping items? Yeah, and if you want to present in the room, you have to bring your laptop. So it won't work very well to just use the existing system because it won't really look like you're presenting, which wouldn't be good. Yeah, so. Okay, any questions, further questions for Ishita? So thank you very much. It was a great session and yeah.
Thanks so much for your participation and attention. I really enjoyed talking to you guys.
Okay, so that's it. Thank you very much. Take care now. Bye-bye.